Good. That one's already nice and set up for it. All right, Brian, for number 3, or for C.
I didn't really get these. I was really confused on these. I was trying to figure it out. I think that would be not number C, for C. Wouldn't that be the quadratic formula?
Yeah, I'd personally probably try quadratic formula. I'd subtract the 11 over first, and then I would try quadratic formula because that 14 and the 11 seems kind of a pain to factor. So personally, I would try quadratic formula first on that one. That would be my attempt. Did anyone say factoring on that one?
No, it's
No.
quadratic.
Okay, yeah, because you would have had negative 154
Yeah.
would have been the top of your x, which is kind of
We don't
gross.
have ECF and we just go straight to the quadratic.
Yeah, that's what I would have done. All right, next one. 151A, Ganya, you're next for that group.
151, okay, we'll look at it because I'm looking for 150. Okay, 151, it's 6a squared plus 14 equals to 20. I wanna say this one is a square root.
Good. Yep. On this one, we only have the a, and the a is squared. So if we
Yes.
move everything over to the right, we can just square root and we're good to go.
Yes, because I just looked at it. Okay, square root.
Good. Awesome. Let's see, Joshua, you're next, room 2.
This is for 151B.
Yep.
Did a square root.
Good. Awesome. Already set up for it, right? Using the square root right away, plus or minus, and then add the 1/4, and you're done. Cool. All right, next is Vanessa for room 2.
Maybe I did quadratic.
You could do quadratic. I'd probably try factoring first since 8 is a very small number. Yeah, I'd move the 8 over and factor. And if it didn't factor, then I would do quadratic. So I would put a factoring first. Yeah, just because 8 is pretty quick to break down, like 2 times 4, that's going to give me that -2 automatically. So it's quicker. Yeah. All right. Did anyone do 150? Want to go through 150 real quick?
Yes.
Real quick, 151A was a square root property.
Uh-huh.
Okay, thank you.
Yeah. So what about 150A? For those of you who did it, or if you didn't do it, look at it now. What do you think it would be?
Square root.
Yep, it's already set up for square root. I would square root both sides, then subtract the 3, then divide the 8. So that one's already set up for square root property. What about B?
I want to say here it's quadratic.
You
Factor?
could, I'd probably do factor because 22 is 11 and 2, which will give me 9. So that's pretty
We
quick.
have 2 and yes.
Yeah.
Right.
If factoring doesn't work, then you go to quadratic.
Yeah, in this case it's fine. Yes.
What about C? What do we think for C?
For C, I want to say it's square root.
Yep, C is just like 151A. We can move that 10 over, then divide the 4, and then square root. We're done. All right. Cool. Any questions on these before we actually go and start solving some stuff?
You know what I did here, the teacher? I did all the homeworks for the practice. I didn't look at the book.
Well, that's okay. You got practice.
Yes,
You
I
got
did.
more practice. All right. So let me clear this so we can see it better. So let's do 25, 45. So let's do 25 for sure, because that one we should be able to do 25. 45, y'all can see already. And then 47, you can't see. So I'll share the book again, but you have the book. But I'll share it again in case anyone wants to take a quick screenshot. Here's which one is 47. It's confusing the way it's numbered above.
Could you enable sharing so that we can show it on our end?
Receivers would have to enable it. But there's 47 because you can't see it on the worksheet very well. So if anyone wants to take a screenshot or a picture, or you can open your book, you have access to it. Anyone still need it?
No, it's okay. Take pictures. Thank you.
Everyone got it? All right, cool. So let's go back and do those three that I just put in the chat. Again, I know it's sort of funky how it got cut off here. So it says find the coordinates of all intercepts. So when we look at all intercepts, we look at what kind of intercepts do we have on a problem? There's two kinds we have to find. What are the two kinds of intercepts?
Oh,
X-intercepts and
yeah.
The
the
vertex.
y-intercept. Yep. In this case, though, these problems will only have one y-intercept because they're all parabola opening up or down. So they're only going to hit the y-axis once. So you'll have two x-intercepts, assuming it's hitting it twice. See, look, this one has 2, right?
Yes.
So you're going to get two x-intercepts and you're going to get a y-intercept for that one. Now you have to find it. You can't just use the graph and pick a random number on there. You actually have to use this formula and find it. So you might have to do quadratic formula or factoring or something. You can't just look at it and say, oh, that looks like 2.
Oh, okay.
You
The
need to
easiest way
actually
is just
solve.
to graph.
You need to actually solve it, okay? So actually solve those and get that number, and then that looks like -5, but make sure your math supports it. So you need math to support your answers. Okay. All right, let's go back to groups and work on those 3. I think what happened is whoever made this homework worksheet thought 48 was 47 because 48 is not assigned, but it's in the picture and 47 is not in the picture. I think that's what happened. But 48 is a good one to look at too. Doesn't matter. All right, I'll be right back. I'm gonna go up here. So x plus 5. Okay, and then what do we do from there?
You set x plus 5 equal to 0.
Mm-hmm.
Get x equals -5.
Okay, and then
So do you put the 1 on the other side? And oh yeah, do negative 1/3.
yep, positive 1/3, I think, right? Because it's +1 when you add it over.
Oh yeah.
So something I kind of want to point out is this is not a point. So I saw a person or two on the test, this test or the last test, who wrote this as a point. This is not a point. These are 2 x's. This is wrong. It's not a point. So if you're writing it as a point, you're not doing it correctly. It's just 2 x's, especially when we get into functions that have a y, then you're misrepresenting your answer for sure. Okay. All right, cool. Thanks, Carson. Okay, let's go to the next
Teacher,
one.
I have question, please.
Uh-huh.
Before we move, I have question for the 25. Me, I solved just as we have x times 3x plus 14 equals everything equals to 5. I just put x equals to 5 or x plus 14 equals to 5, and then I solved them. One it's x equals to 5, another one x equals to -3.
Okay, so if you're thinking about doing something like that, you're saying that these 2 numbers, whatever they are, I'll just put blanks. These 2 numbers multiply to equal 5, and you are assuming that one or the other is 5.
Right.
But couldn't it be like a 5th times like 10? Couldn't it be 1 times 5? Like a lot of things multiply together to equal 5. So you can't just split it like that. That only works with 0 because 0 is like a pretty handy number that when we multiply 0 by anything, we get 0. But if you split up a 5 like that, you have no idea what those 2 parentheses were to multiply to get the 5.
You mean the only method we can do if we have just equals to 0, no equals to the number.
Exactly, because you have no idea what numbers multiply together to equal the 5. What if let's say it was a 50, right? It could have been a 2 times a 25. So one of the parentheses could have been a 2. One of them could have been a 25. It could have been 1 times 50. It could have been 10 times 5. Like you have no idea what those two parentheses represent to multiply together to give you 50. So we can't do that with any number except 0, because 0,
Because-
we know for sure one of them must be 0, like for
Yes.
sure.
Because I'm always trying to ask this question, but I forgot. Okay, thank you.
Does that make more sense why we can't
Yeah,
do that?
yeah, now it makes
Okay.
so. Yeah, thank you. I
Okay,
appreciate it.
good. Yeah, no problem. All right, 45. Who's next? Fidel, you're next. Can you help with 45?
I was actually having trouble with this one. I didn't get it.
Okay, what did you start to do, or what did you think about starting to do?
I would turn the y into 0.
Okay, so when you do that, that means you're finding your x-intercepts. So remember, we got to find x and y. So we're starting with x, if you're setting y equal to 0. And then what do you think here? Factoring, square rooting, completing or quadratic formula? What do you think? Which method do you want to do?
Could we do quadratic?
Yeah, we can. Factoring would work with this one also, but if you want to mix it up and do quadratic, we can. A, B, C. So x equals negative b. I'm just filling in the formula. Plus or minus square root b squared minus 4ac all over 2a. But again, factoring would have worked here as well. All right, use your calculator and let me know what you get under the square root. 13 squared minus 4 times 6 times negative 5. Let me know what you get.
So 13 squared would be 169.
Uh-huh.
Then
So 169, and then what's the other one going to be? Here, I'll put an arrow. That's 169, and then 4 times 6 times negative 5. Negative 4 times 6 times negative 5.
be 120.
Okay, so 169 plus 120. I believe the inside was 189. That's what I got. Oh, 289, sorry, not 189, 289. Is that what you got, Fidel?
Yeah.
Okay, can we take the square root of 189? Try it and see if it gives us a nice number. 289. Oh, I got 17. Did you get 17?
No, it's not 17.
Not as the answer, as the square root.
Okay, sorry.
Okay. Want to make sure Fidel can get it in his calculator.
Right.
Okay, so now what do we do?
Does that say negative 13?
Yep, because it was negative b and our b was.
All
negative.
right. Kind of forgot. Let's see.
So we're gonna split it into our two answers, our plus and our minus.
Oh, right. Right. So it'd be plus.
Go up here, since I'm running out of space. So we have
Plus or
x
minus, right?
equals, yeah, negative 13 plus 17 over 12. And x equals negative 13 minus 17 over 12. So solve both of those and let me know what you get for x. Oops, 12, not 10. I don't know why I wrote 12.
So it'd be negative 13 minus 17.
That's one of them. And then we'll divide it by 12.
Negative 2.5.
Nice, that's what I got. Good. And then try the other one. We'll see if we get the same thing there too.
It'd be 4. Oh,
And then
divide.
divide by 12. Yeah, don't forget that part.
Right.
So then you got 0.3.
Yeah.
Cool. So those are our two x's. So now tell me how I write those as points because I want the x-intercepts. So what's my answers? What are my answers for that? I'll write it in red up in the corner.
Would it just be x equals?
Well, we want intercepts, so we actually want the actual points now. So we got 0.33 is our x. What was our y? What did you make the y to be at the beginning?
A 0.
0. There we go. And then the other point? What's our other x?
It'd be 13.
I don't think that was our x. What was the second x we got? We got 0.33 and,
Oh, negative 2.5.
okay, so write that as a point. So negative 2.5 comma what?
0.
0. Okay. So those are our x-intercepts. We're not done yet. We got to find our y-intercept. So how do we find our y-intercept?
Teacher, sorry guys, I will just stop you 1 minute, 1 sec.
Uh-huh.
Our function is 6x squared plus 13x minus 5.
Yes.
But when I did the AC method, for the x's, when I factor it, I find my x is 1 equals to minus 2, another one equals to 15 with the AC method.
Uh-huh. And then you still got to factor from there. You got to keep going.
Yes, I am now I have my 2 points as minus 2 0 and 15 is 0. When my for the x-intercept, when my y equals to 0, right?
So you had negative 30 on top and 13 on the bottom. So you got
Yeah.
negative 10 and negative 3. Oh, wait, no, that won't work. 15 and 2.
Yes, it works with AC method. 15 and minus 2.
Uh-huh. And then you split up the middle. So 6x squared minus 2x plus 15x minus 5.
Mm-hmm.
And then you do your factoring. So you take out a 2x. So 3x minus 1. And then you take out a 5. So that's 3x minus 1. So then you get 2x plus 5. And then at 3x minus 1. You're getting the same answer. Yeah. So 2x plus 5 equals 0. So x equals, that gives you 2.5 as well. And then 3x minus 1 equals 0. That also gives you x equals 1/3, which is the same thing as 0.33333.
Okay.
So we're getting the same answers. Oh, I forgot my negative on this one. Negative.
Okay, thank you.
Yep. So whether you did it with factoring or quadratic formula, you have the same thing.
Yes, I want to just make sure. Okay, thank you.
All right, Fidel, how do we get our y-intercept? We got our x-intercepts. How do we get our y-intercept?
You plug it back in the formula.
But if I plug the x back in, aren't I just going to get 0? Isn't that what, like if I plug in this again, I should get y equals 0, right? Because we made y equal to 0. So that's not going to give me anything new. So think about this. When I want my x-intercept, I make y 0, right? So now what if I want my y-intercept? What am I going to do? Make what?
X 0.
You're going to make x equals 0,
Yeah,
right?
x 0. Yep.
So,
So let's go back to our original problem and we're going to make x 0 now. Okay, so it flip-flops. If I want my x-intercept, I make y 0. If I want my y-intercept, I make x 0. Now I'm trying to erase all this stuff so y'all can see. That's good enough.
So
So
with this
go back.
particular problem, finding the y-intercept is actually quite easy
Oh yeah, for sure.
because it's just all
Whenever it's in
canceling.
standard, yeah, whenever it's in standard form, it's super easy to find the y-intercept because that's 0 and 0, right? So y equals 0 plus 0 minus 5. So y equals -5.
Quick question though, with the X integers, we have decimals. Should we change those into fractions or is decimals okay?
The reason I went with the decimals is because I'm looking at my graph at the end and I'm going to verify that it makes sense. So I went with decimals for this problem. Typically, I leave it in fraction form by habit because fractions are more accurate. But because I have the graph, I went with decimals so I could check my answer at the end.
And then for upcoming tests, what should we do? Should we just
I
do
think
both
we're
to
fine
make
with-
to be
right with
safe or?
either.
Okay.
I mean, if there's a graph, I would probably, I don't know, Professor Sievers, if there's a graph, are you cool with them putting it in decimal form so it's easier for them to check it like I'm doing?
Are there solutions? What are you talking about?
Yeah, see how for this problem, I didn't leave it as 1/3 of -5/2. I put it in decimal form so I could check the graph. Is that how we kind of want them to do it for a test if there's a graph?
Yeah, I mean,
Because in the work, I had 1/3 and -2/5, but then I changed it into, I mean, yeah, -5/2.
yeah, typically you convert it to a decimal if you're gonna graph it. I would say like as far as 1/3 and -2.5, like you could probably pretty much guesstimate whether it's hitting the right part or not. Solving things with graphs is not really the way to go for the most part.
No, they're asking if it's okay to write the solution as a decimal, because normally we've been writing them as fractions, and I did this one as a decimal because we have the graph. So at the end, I'm going to have them look at the graph and see if it makes sense.
I would say if they're doing the solution, I probably want the solution to be precise, like 1/3.
But if it's, so you don't want it as, okay, so I'll change it back then. Okay, we'll change it back. But you can change it into decimal form to check your graph. Because a lot of times students don't know what -5/2 is as a decimal to check. So you're welcome to put it in decimal form on your calculator to check the graph. Okay. All right, Fidel, were you okay with getting the y-intercept? I want to check back in with you because you didn't know how to start with it originally.
Yeah, the y makes a lot more sense.
Okay, so we're almost done. I need you to write it as a point still. And then we're done with this problem. So we got y equals -5, huh?
As a point, you said?
Uh-huh. So I know my y is -5. What was my x?
Didn't we have 2 x's?
Not for this part. Look, we only had one x. What was the x we plugged in?
Oh, 0.
0. There you go. Don't mix them up. Don't mix up your x-intercepts and your y-intercepts together. Don't mix them. So now we can look at our graph and we can check to make sure that these answers make sense, which we should do at the end of our problem because we just did all this math. And what if we typed it in our calculator wrong, right? So we're going to go back and look. Does this look like -2.5 on the x? That looks like -2.5 to me, right? Looks pretty good. And then does this x-intercept look like 0.3333 forever? Third. Yeah. Okay, let's check our y. Does this y look like it's hitting at -5, which is what we got?
Yes.
Yep, there you go. So it's a great way to check when you have that graph there at the end to make sure your answers make sense.
I have a question.
Sure.
So if I'm not mistaken, our intercept and stuff, it will always be 2, like 2 different and then y would only be 1.
Well, it depends how many times it hits the x-axis. That's what we're figuring out. So let's say my graph, what if my parabola looked like this? How many times does that hit the x-axis?
0.
Yeah, so that one wouldn't have any real solutions. That's when we get that imaginary stuff that we talked about before.
Okay.
Or what if my graph looked like this, where the vertex, which for that vertex formula we did last unit, was right there. That means I should only get one answer because it's only intersecting the x-axis once. So how many x-intercepts you get depends how many times your function intersects the x-axis. So in this problem, we better get 2 because look, it's intersecting it twice.
Okay. Gotcha. I noticed when I was taking notes, I wrote that so wrong. That's why I feel like that's a reason why I've been kind of getting stuff with graphs confused because I'm like, it's not clicking, But
Yeah.
I'm just trying to fix my notes.
Yeah, it's all good. Anyone else have questions on that?
Yeah, I had one. So just trying to figure out, well, I kind of lost it now, but if I remember it again, I'll ask later.
Okay, sounds good. All right, any other questions before we go on to 47? Okay, so I'm going to switch the textbook since I can't see 47 over there. All right, Michael Fowler, you are next. So we're doing 47.
I am so lost and completely stumbling through all of this. Trying to set it up in the quadratic formula.
Okay, so you want to find the x-intercepts first, right? That's what it sounds like.
Yes.
Okay, so to find the x-intercepts, we have to make y 0. So let's start by writing that. And then you said you are plugging it into the quadratic formula. So let me identify the letters, the variables. All right, and then I'll set it up and tell me if you have the same thing. So negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. Do you have the same setup?
I skipped a step even in the setup. I started trying to just get the numbers for the formula, I guess, inside the square root.
Oh, okay. Yeah, I usually like to write it all first and then put the inside of the square root in my calculator because that usually makes the inside simplify pretty quick. So if we put the inside in our calculator, so 12 squared minus 4 times -4 times -9, then we can see what we get inside the square root. So let me know what number you get inside the square root. Everybody should be doing it in their calculator so you're getting that practice.
Minus second.
I got 0.
Okay. Did anyone else get 0?
Yes, 0.
Okay.
I must have been wrong. Yeah, I got a error, no real answers.
Make sure you're putting your parentheses. Maybe that's what's messing it up. So 12 squared minus 4 and then parentheses -4 and then another set of parentheses -9. But I got 0 also. So I think it's 0.
All right, hold on. X 12.
So if we take the square root of 0, that's 0. And then -12 plus or minus 0 doesn't matter. We're still going to get -12. So then I just reduced it and I got 3/4. So this goes back to what Ashley was asking. On this answer, notice I only got 1 x-intercept. So why did I only get 1 x-intercept versus the previous problem I got 2?
Because it's only touching the X once.
This is the X once.
Exactly, that vertex right there is on the x-axis, so it's only intersecting one time. So that's why I only got one x-intercept. All right. What about the y-intercept?
And then you'd have to run the same equation again, plugging in for
If I want y, what do I plug in for x?
0.
0, good. So I want y, so I make x 0.
Shouldn't the x-intercept be 3/2?
Did I simplify it wrong? Divide by 4. Oh, is it 3/2? I might have simplified it wrong. Let's see. Divide by 4 and 4. Yeah, there you go. 3/2. So I hope everyone gets the y-intercept right on the test. I think the y-intercept is the easiest part as long as you remember to plug in 0 for an x. And it's in standard form. It's so easy because everything just cancels out, you know?
Teacher, the y-intercept for the first one, when x equals to 0, the answer is 1/4, right?
I got, oh wait, I still didn't erase that 4. Hang on, Charmaine, I see you taking a picture. Let me erase that 4. That was a typo, righto. There you go.
Okay, gotcha. Making sure.
Yeah, now you can take a picture. Yeah, the x-intercept was 3/2 0, and then the y-intercept is 0, -9.
0, you said.
I'm sorry?
I'm asking about the first one, when for the y-intercept, when x, oh no, for the x-intercept, when y equals to 0.
Yes, we got
We
3
got
halves.
just one real number, right?
We got 3 halves. Is that what you were asking?
3 halves. But when we have minus b minus something over 2a, yes. Oh my God. Hey, I used the -4. I didn't use the 12. Sorry.
Oh, okay. All right. Any questions on this one?
Yes, I have a question.
Mhm.
I always got a question. So I understand how x can have more than one intercept because how many times it goes through. Would that be the same for y?
It could be. Right now, we're only dealing with parabolas that open up and down, so they're only hitting the y-axis once. But there are definitely parabolas and functions that exist that, let's say, what if it was like this? Then that hits the y-axis twice, right?
Okay, gotcha. Yeah, because I was at the beginning of class, I'm like, something with graphs, it's just not clicking, but I'm just trying to X out the questions I can,
Yeah, of course.
It wouldn't be a function though. It'd be a relation or something.
Exactly.
Yeah.
But there are graphs that exist that will have multiple, even more than 2 x-intercepts. I mean, I could draw a graph that looks like that, and look, that has 1, 2, 3, 4 x-intercepts, right? I mean, the amount of answers is just going to depend on how many times it intersects that axis that you're looking at. So that's how many answers or solutions you'll get. All right. Any other questions on this one? Okay. Oh, what? Does someone have a question?
No, I said no.
Oh, okay. All right. 49, I believe, was next, and 49 is not on your packet. So I'll leave it up here for a second so y'all can take a picture. There's 49 if you need to take a picture.
Did you mean 48?
It says 49 in the assignment. That's why I was sharing it right here.
Oh, there was 48 on our paper.
I know. I think whoever made that accidentally put the wrong one. So that's why I was sharing the textbook. But y'all have the textbook too, so you don't have to take a picture if you don't want to. So just before you go to your groups, how many x-intercepts should this one have? How many answers should you get for your x-intercepts? 2, yep. And how many y-intercepts should you get?
1.
Yep, there you go.
But
So
we need to calculate them. We can just say one.
I know. I was just prompting. Y'all to think about how many you're gonna have.
I'm sorry, would we be able to go back to that sheet? I didn't quite get the picture of it.
Okay. It's this one.
Okay, thank you so much.
Yep, no problem. All right, 49, and then we're doing 51, which I'm guessing is just this one. It says 51A, but I'll scroll down just to make sure. Yeah, it's just 51. So 51, and then we are also doing 53, which is more, oh, that one looks maybe like factoring. Oh, that one looks like factoring too. Cool. And then what else? Let's do those 3. I think that's a good start. Let's go back to groups. Okay, and then for x-intercept?
I did the quadratic formula.
Oh, it didn't factor nicely?
Oh, I didn't even try
You
to
didn't even
factor it.
try?
I just
Okay,
went straight to the formula.
okay. So let's see, x equals -b plus or minus square root b squared minus 4ac all over 2a. So what'd you get under the square root?
49.
Oh, look at that. That's nice.
Yeah. And then
Okay.
it ended up being 7.
Okay. And then split it into the 2. So what was that? Is that -4 over -6?
Yes.
So then 2/3?
Yes.
Yeah.
Oh, what you got? Okay. And then
2/3
this,
for
and then this one is at -18 over 6, -6. That one looks like
actually I got
3.
3.
Okay. And then don't forget, you have to write them as points, right? Have to write these as points.
So my x-intercepts were 2/3, comma 0. And then the other one was 3, comma 0.
Nice. Okay. So that one probably did factor, but it's okay. Quadratic formula works. All right. Any questions on that one? No? Okay, let's go to the next one. So now I can go back to the regular paper. Here we go, 51. All right, so 51, where are we at? Who have I not called on yet? Let's see. Jade, can you do 51?
Charmaine saying, or I could do one too.
Oh, sure, you can do it. You can do 51 if you want.
Okay, so what I did was X times, okay, so I factored out, one moment. So what I did was I had X times, and then in parentheses, X plus 2 equals 0.
Okay.
And then, so then you got X equals 0, or and X equals -2.
Yep, cool, awesome. That's good.
Great.
I have a question.
Mhm.
So I thought, well, in my group, we was asking, do we factor it or do we supposed to graph it?
Yeah, so before y'all went to groups, I said we were just gonna do factoring and quadratic formula and all that good stuff. Because I don't think on the test, we're gonna give you that and then ask you to solve it using a graph. You might use the graph to verify it like we've been doing. Or later on in later sections, like tomorrow and the next day, we're gonna do other stuff with graphs. But for now, we're just practicing using what we've been doing, and then we're verifying if there is a graph, we're verifying the answers. All right, what was next? Was it 53?
think I also showed them in the notes how to use their calculator to check those sorts of things with graphically.
Yep, you can also put it in your calculator to check it. All right, 53. Who was doing 53? I think I was asking Jade, but I'm not sure if Jade is there. Jonathan, you want to do 53? Jonathan?
I was talking, it was muted. You can do the
Oh.
quadratic formula.
You can. Yep,
So
we can
but you-
do it.
Oh, could you, which one's easier though? I guess,
Factoring. Factoring's easier, but we can do quadratic formula if you want.
was that mean you can do the little X, the
Yeah.
AC formula?
You can, but
Okay.
like I said, we can do quadratic formula if you want. I'm just writing it out.
Holy cow.
So start simplifying. So we have a negative -1 in the front. So that's just a 1, right?
1, yeah, 1 plus or minus -2
Put that in there.
minus
We'll just put that whole thing in the
-2.
calculator.
No,
Because that's going to be -1 squared is 1. So
1, sorry.
1.
1 minus 4 times -6. -4 times -6 is 24, so positive 24.
So I think it's 25 in there. Because it's 1 plus the 24.
Divided by 2.
We can't divide it by 2
X equals
yet.
half.
But hang on, we can't divide it by 2 yet. We got to split it into the 2 problems, remember? Because we have a plus or minus in the middle.
And then
So you got
what
to
do you do
split
from
it.
there?
We got to do the positive version, x equals 1 plus 5 over 2. Solve that. And then we also have to do the
Oh,
negative version.
Okay, so one of them will be 3.
Yep,
So it'll
this
be
one's
like
3.
1 plus 5 is 6, 6 over 2. And then 1 minus 5 is -4 over 2, and that'll be -2.
Yep, cool. And if we were writing it as intercepts, which this problem doesn't say we need to, there's no y actually in this problem. So technically we can just leave it like that. Because this problem doesn't even have a y, it just has a 0 there. So we can just leave it as x is 3 and x is -2. All right, I wanted to make sure we get to the ones with the discriminant, so we can talk about those real quick. So over here, I believe 121 was assigned. So from the notes, do y'all remember when is a greater than 0 and when is a less than 0? How do we know graphically? When is a greater than 0 graphically and when is a less than 0 graphically?
Up and down.
Up and down, right? Yep.
Yes,
A is greater than 0. That means it's positive, right? Greater than 0 means it's positive. So that's when it's smiling. It's smiling. It's going up, right? Smiling parabola. And then A is less than 0. That implies that it's negative. And that's when your parabola is sad. So your parabola is going down because it's negative. It's a grumpy parabola. So that should help us answer A for all of these problems. So you all can just shout out for 121, is A greater than 0 or less than 0?
Greater.
Greater, okay. 123?
Greater.
Okay. 125?
Less than.
Less, yep, that's it. So that was A for all 3 of those.
Which 123, it's greater, 125?
It's less.
Okay.
Because it's a grumpy parabola. Okay. Any questions on that A being greater than or less than 0?
Yes, I have a question. So, so like for the answer, we'll just put like A greater sign 0.
Yep. That's it.
Yes.
Okay. Solve the equation, part B. That's just asking for the intercepts. So let's do 121. Now we don't have an equation this time, so we are going to have to use the graph to estimate. So somebody shout out, what are the x-intercepts for 121? We're doing part B. Someone shout out.
Negative 6, 0,
Uh-huh.
and 2, 0.
Okay, and then what's the y-intercept?
0, negative 6.
Yep, awesome, done. Because there is no equation, so we can't do what we did previously where we actually factored and solved. On these, there's no equation. Any questions on that? Just doing it visually?
I have a question. I see what you did, but what's the name of that again?
These are the intercepts. So the first two are called the x-intercept because those have the x solved for, right? And this one was the y-intercept. These are the intercepts.
Okay.
All right, for C, does anyone remember all the discriminant information? How do we know when the discriminant is positive or negative or 0? How do we know these things?
It's a positive if it has 2 real zeros.
Perfect.
It's 0. The discriminant is 0 if it has 1 real zero.
Okay.
And it's negative if it has 0.
I'm just writing this again in case y'all don't see it in your notes right away. Negative if 2, what'd you say? What was negative again?
0 if it has 0.
Real zeros. Yeah. And I'm going to write in parentheses, this would have complex or imaginary, just so you know that's where that would go. We're just not doing it just yet, but I'm just writing it in parentheses. When we say 0 real zeros, that means there's imaginary zeros. Okay. All right. So looking at number 121, how many real zeros do we have?
2.
2. We have this real 0 and this real 0. So is it going to be a positive discriminant, a negative discriminant, or a 0 discriminant?
Positive.
Positive, yeah. So positive discriminant. Onward. Okay. So just briefly looking at the next problem, 123. How many real zeros on 123?
One.
So what kind of discriminant?
0.
0. The discriminant is 0. Yep. Okay. And I'll scroll down so we can look at the last one. What about the last one? How many real zeros?
None.
Yep, none. Doesn't hit the x-axis at all. That line doesn't have any. So that means the discriminant would be?
So no real zeros, okay.
So the discriminant would be?
Negative.
Negative.
Yep, exactly. All right, so we got through almost all of them. I know we're at time, but hopefully that helps you finish these couple. We did most of it together. Okay. All right, some of your tests are out, some of your tests are not out. So if you did get an email notification, feel free to look at your test. If you want me to put in fake scores again, like I offered to do last week and the week before, I can. We can meet and I can put in fake scores for the next couple tests to see what you need to get the grade you want, if it's possible, what your grade is. So let me know. All right.
Right. Thank you.
Bye. See you tomorrow.
Thank you. See you tomorrow. Have a good evening.
Have a good one.